Hello, everyone. Welcome to my channel. I'm Thomas, and this channel is all about uh, educational enrichment, learning new subjects that are maybe pretty obscure but are vitally important if we um, if we actually learn them. Things that we have not been exposed to, but through my research, I have come across these topics and I've tried to put them together and presented them. Sometimes, I would just present them to the best of my ability because some of these subjects are pretty difficult, and I can't say that I'm an actual expert on them, but I've learned enough to at least try to present them coherently. And today is the 167th video that we've done on the reciprocal system of theory. This is a theory from Dewey B. Larson. He died back in 1990, and since then, a handful of people have been trying to put forward his theory and refine it even more. Some of those people have also passed away now. So we're just trying to kind of pick up the pieces and carry the theory forward and bring it to people who haven't heard of it yet. Um, Now, the basic idea behind the reciprocal system, it is a system of theory, not just a theory, but a system. So it's like if you understand it, you can plug it into whatever subject you'd like to plug it into. It's universally applicable. And the general idea is that we live, according to Larson, in a universe of motion. And this is different than the legacy scientists who, the ancient ones, would have told you that the um, universe was made out of matter. And then the Einsteinians would have said, oh, well, it looks like it's made out of matter, but it's actually made out of energy. And Larson really takes the E equals mc squared and says, well, if energy equals matter times the speed of light squared, that means that energy can be converted into matter and vice versa, which means that neither one of those things can be the most fundamental thing. And he posits instead that the c squared part, the motion, is what is more fundamental. And he also gets a leg up because he defines motion as the relationship between space and time. That creates a generalized reciprocal relationship between space and time, hence the name reciprocal system. Space and time are both components of a fraction that is motion. Originally, Larson actually used the term space-time, but then he changed it to motion. But motion is just a fraction with space and time as the space or time as the numerator, and time or space as the denominator. Space and time, as reciprocals, are really the same. Um, they have the same qualities, other than they are reciprocals of each other. Just like 2/3 and 3/2 both have the same qualities, 3 and 2. Uh, Time and space both have the same qualities. Uh, one being that they are coordinate, meaning they both have 3 or more dimensions, and the other that um, they both progress, or Larson calls this clock time or clock space. They both progress in a scalar manner. Scalar motion is a motion that has a magnitude, but it has no particular direction. So, you take a balloon, you put some dots on the balloon with a magic marker, and then you blow up the balloon, all of the dots are moving away from each other. That is an outward scalar motion. And now, if you suck in the balloon, then you have an inward scalar motion. All the dots are moving toward each other. And even legacy science has backed this up with the um, contention from the Hubble telescope that uh, all of the distant galaxies are moving away from each other. That is the progression of space, which is the corresponding, um, quality to the progression of time. Now, you may doubt the legitimacy of the Hubble telescope and even the legitimacy of space itself. Um, Larson accepted those things, but I do believe that even if those things are not true, that the reciprocal system would be able to reconcile that, and it may eventually be able to reconcile that. I'm hot on the trail there. Um, and then also, space and time are both quantized, meaning that they both uh, have a minimum unit. There's no, um, you know, 2/10 of a unit. Uh, Either you have 1, 2, 3, 4, 5, or you don't. If you have zero point 0.2, then you really have zero. If you have 1.3, then you really just have one. Space and time are both quantized. They both come in chunks. And 1 unit of space in 1 unit of time is the speed of light. So the speed of light is really the background of this universe, the origin of this universe. And where Einstein says that the speed of light is the maximum speed of the universe, Larson would say that the speed of light is the midpoint of the universe, and there is an entire half of the universe that's moving faster than the speed of light, which Einstein considered to be impossible. It was just that he didn't have the capacity to actually see that or understand that, because the motion in time is manifests itself differently than what you would think. Okay, some of this maybe will become clear as we go through this chapter. We are looking at his 1979 book that is called Nothing But Motion. And this book is primarily on physics. And we are in chapter 8, which is called Motion in Time. And so when you have a motion in space, that motion is motion at less than the speed of light, and that's the motion that we're accustomed to. But you can also have motion in time, which is a motion that is faster than the speed of light, and that manifests in time. But we don't see time, we only see space from our vantage point. And so when we see something motion in time, we see it really as its inverse in space. So an example of that, again, using astronomy, is what you call a supernova, an exploding star. If that exploding star explodes into time, meaning faster than the speed of light, we see it as an implosion in space, and hence phenomena such as a white dwarf star. But there's also the ability to have a motion in time that is in less than a unit of space. Again, we said that space and time are both quantized, meaning there's a minimum unit of time and space. If you get inside that unit of space, you have a world of nothing but time, which Larson calls the time region. So motion can also be in time if it is inside 1 unit of space, because inside 1 unit of space, space does not exist. You only have time. And vice versa, if you're inside 1 unit of time, time does not exist. So you have only motion in space. Okay, now we're going to, this chapter is called Motion in Time, and he was just going over some of this, and so we'll let him start right here. Any kind of action originating in the region where all motion is in time is also subject to significant modifications if it reaches the unit boundary and enters the region of space motion. For example, the connection between motion in space and motion in time is scalar because there is no relation between direction in space and direction in time. Consequently, only one dimension of a two-dimensional or three-dimensional motion can be transmitted across the boundary. This point has an important bearing on some of the phenomena that will be discussed later. Another significant fact is that the effective direction of the basic scalar motions, gravitation, and the progression of the natural reference system reverses at the unit level. Okay, so those are the basic scalar motions. The progression of the natural reference system. This is, where the speed of light is the background. Larson, legacy science takes their measurements from zero, but Larson takes his measurements from the speed of light, moving outward in all directions. That is a scalar motion at the speed of light. That is what he calls the progression of the natural reference system. And gravitation would be visualized by that sucking in the balloon. So that is an inward scalar motion. And the effective direction of the basic scalar motions, gravitation, and the progression of the natural reference system reverses at unit level at the speed of light. Or unit level is also the minimum unit of time or the minimum unit of space. Outside unit space, in our familiar, beyond the unit of space is actually like 4.56 times 10 to the minus 8 meters. 4.5 times 10 to the minus 6 centimeters. So it's very small, but it's very large compared to the size of an atom. Outside unit space, the progression of the reference system carries all objects outward in space away from each other. Inside unit space, only time can progress unidirectionally. And since an increase in time with space remaining constant is equivalent to a decrease in space, the progression of the reference system in this region, the time region, as we will call it, moves all objects to locations which, in effect, are closer together. The gravitational motion necessarily opposes the progression, and hence the direction of this motion also reverses at the unit boundary. As it is ordinarily observed in the region outside unit distance, gravitation is an inward motion, moving objects closer together. But in the time region, it acts in the outward direction, moving material objects farther apart. Okay, so what he's saying there is normally when we think of gravity, we think of an inward motion that's moving things closer together. But if you get into this atomic realm or this molecular realm inside a unit of space, the relations reverse. And actually, gravitation is actually pushing objects toward that boundary. So you can think of gravitation, really, it moves objects toward the boundary, toward that unit boundary, whether you're outside or inside of it. So the progression outside the boundary moves objects outward. But inside the boundary, the progression actually moves objects inward toward, this center or, away from the unit boundary. So Larson uses this The progression is actually what causes things like cohesion of a solid, um, where things, different atoms within a unit of space actually move closer together, is not because of gravitation, but it is also because of the progression. So you have to, when you cross the unit boundary, you have to reverse the uh, the roles of gravitation and the progression. Okay, on first consideration, it may seem illogical for the same force to act in opposite directions in different regions. But from the natural standpoint, these are not different directions. As emphasized in Chapter 3, the natural datum is unity, not zero. And the progression of the natural reference system therefore always acts in the same natural direction, away from unity. In the region outside unit distance, away from unity is also away from zero. But in the time region, away from unity is toward zero. Gravitation likewise has the same natural direction in both regions toward unity. So Larson basically just said what I said in a more concise and accurate way. And so I apologize to Mr. Larson because I'm sometimes complaining about how verbose he is and how dry he is and how difficult to follow he is. But that time he one up me on the explanation. It is this reversal of coordinate direction at the unit level that enables the atoms to take up equilibrium positions and form solid and liquid aggregates. No such equilibrium can be established where the progression of the natural reference system is outward, because in this case, the effect of any change in the distance between atoms resulting from an unbalance of forces is to accentuate the unbalance. If the inward directed gravitational motion exceeds the outward directed progression, a net inward motion takes place, making the gravitational motion still greater. Conversely, if the gravitational motion is the smaller, the resulting net motion is outward, which still further reduces the already inadequate gravitational motion. Under these conditions, there can be no equilibrium. In the time region, however, the effect of a change in relative position opposes the unbalanced force which caused the change. If the gravitational motion, which is outward in this region, is the greater, an outward net motion takes place, reducing the gravitational motion and ultimately bringing it into equality with the constant inward progression of the reference system. Similarly, if the progression is the greater, the net movement is inward, and this increases the gravitational motion until equilibrium is reached. The equilibrium that must necessarily be established between the atoms of matter inside unit distance in a universe of motion obviously corresponds to the observed interatomic equilibrium that prevails in solids and, with certain modifications, in liquids. Here, then, is the explanation of solid and liquid cohesion that we derived from the reciprocal system of theory, the first comprehensive and completely self-consistent theory of this phenomena that has ever been formulated. The mere fact that it is far superior in all respects to the currently accepted electrical theory of matter is not, in itself, very significant, inasmuch as the electrical hypothesis is definitely one of the less successful segments of present-day physical theory. But a comparison of the two theories should nevertheless be of interest from the standpoint of demonstrating how great an advance the new theoretical system actually accomplishes in theoretical system actually accomplishes in this particular field. A detailed comparison will therefore be presented later after some further groundwork has been laid. Okay, that's the end of the end of chapter 8. And the next chapter is called Rotational Combinations. And so this chapter is going to be getting into what you call subatomic particles, and then eventually to atoms. So atoms and subatomic particles are combinations of rotations. He will eventually, say that there are two primary rotations, and then there is a secondary. There's a primary rotation, a secondary rotation, and then that are both two-dimensional, and then there is a one-dimensional kind of residue of rotation that is one-dimensional. Now, just getting back where I was talking about the word obviously, that word would only be used if he was addressing an audience of chemists and, scientists who already kind of have mastered legacy science. And that's, a criticism that I have of Larson, is I wish he would have written this more for a lay audience to understand. But anyway, I can't really complain. He did what he did, and he did great work. He didn't do everything, though. So we'll pick up the pieces, and we will take over tomorrow, starting with chapter 9 on rotational combinations. Thanks for tuning in.